Hello everyone, today I'm going to demo the new way of doing CICD on a Kubernetes platform. As you may already know, CICD is one of the prominent practices for DevOps, which very much focuses on fast delivery of your applications. Here I'm using Builder to build my container images, using Tekton for my continuous integrations, and finally ArgoCD for my continuous delivery. The names in red colors are the names for the supported version of each component. For example, OpenShift build is for Builder, OpenShift pipelines is for Tekton, OpenShift GitOps is for ArgoCD. You will get full support along with the Red Hat OpenShift subscriptions. Now, what is Tekton? Tekton allows you to create cloud-native CI/CD. Tekton itself is built on Kubernetes native, which uses CRD, Custom Resource Definitions. It is important to know Tekton provides open source components to help users standardize their CI/CD toolings based on standard specifications around pipelines, releases, workflows, build, test, so on and so forth. Let's see what are the differences compared to traditional CI/CD. Traditional CI/CD is designed for VMs. That's why there's centralized server or the centralized instance, which require an administrator to maintain. You will need to install different kind of plugins into the centralized server to cater multiple CI/CD integration points or scenarios. No interoperability with Kubernetes resources, and the administrators also need to manage the persistency from a single centralized server. Lastly, all the configurations are embedded into the same server. While for the cloud-native CI/CD, it is definitely designed for containers and Kubernetes. It is based on a distributed and serverless mechanism. That's why there's no centralized server and no centralized management is required. Each of the pipelines are fully isolated and no dependency from each others. Every executions are running in a containers. There won't be scenarios like the CI/CD server is down and all the pipelines cannot be executed. And it is total zero resources utilizations if there is no pipeline that is running, because it's serverless. You only spawn the containers on demand when you execute your pipeline. Okay. The whole setup definitely is based on Kubernetes resources, and it uses Kubernetes persistent volumes for its storage, and the config for its configurations in the distributed manners. Next, allows me to briefly explain what is GitOps. GitOps is a decorative approach to achieve application delivery. You define how your deployment should be in YAML file or Helm chart, and you store these artifacts in a repository, for example, Git repository. Then the GitOps tools like ArgoCD will pull those configurations from your Git and deliver the deployment for you. So the entire state is in the codes, right? You define your application state in the codes. The Git repo will serve as your single source of truth. All the histories of the state, the changes are kept and tracked in the Git repository as well. That gives you the benefit of tracing the histories, and you can easily go back to the previous state of deployment. The tool I'm using to do the GitOps is ArgoCD. Basically, ArgoCD is implemented as a Kubernetes controller, which continuously monitors running applications and compare the current state with the desired state that you define in your Git repository. Once it detected the drift, it will take actions and synchronize into your deployment environment with the latest changes. This is a continuous process, so it will go back to monitors and keep in the loop of this deployment process as shown in this diagram. Now, this is the pipelines and also the flow that I'm going to show you later, right? So as a developer, I'll be working on the my applications coding in my local PCs. Once I finish my coding, I'll commit my source code into a Git repository. And once I commit my source code into the Git repository, it will trigger the Tekton pipelines with the webhook. And then it goes through the whole steps within the pipelines, like for example, fetching the source code from repository, do the packaging, build images, and deploy into my first environment, which is my SIT. My SIT is hosted in OpenShift in AWS, and at the same time, I have my UAT environment sitting on the same OpenShift on the AWS. While my production environment is sitting in OpenShift in a Azure cloud. So now, my pipeline will deploy my application into the SIT within the Tekton pipeline itself. After it deploys, it will push the images into my image repository. In this case, I'm using Red Hat Quay. The last steps it will do is it will update the Git repository with the latest deployments configurations that is using the latest images I just pushed into this image registry. So the ArgoCD will detect from this Git repository, and it sees that there's a new images release, and according to that image information, it will pull that latest image from my Red Hat Quay, and it will deploy into my UAT environment automatically. Next, it will deploy into my production environment. But this required some manual steps, which can be act as a approval process in between. Now, let's move to my demo. Okay. So for my local PC development, I'm using VS Code Studios. So I have an application, a Java application here that is built using Quarkus. Quarkus is the next generations of Java framework. There's another name called Supersonic Java that gives you the benefit of resource optimizations in terms of CPU and memory, where you can run a Java applications in a very low CPU and memory consumptions, but without sacrificing the capability of serving the amount of the workload or TPS. Okay, So the application here is a very simple API. So basically, it will return a message and then followed by the local host name, right? So let's go ahead and start this um, applications in development mode. Okay, so Quarkus allows us to do something like live coding, where we can make changes into our code and the effects will immediately um, deploy into the server without manually restart the server. Okay, so the situation is like when you change some coding in HTML, right? The moment you just refresh the web page, whatever changes will be shown, right? You don't have to restart the server. Same thing applies here. Okay, so let me pull another console here. So now this application is running locally, so I'm going to make a curl into my local host. So the return I expected to receive will be like testing from and then my host name. Okay, so now I'm going to change my message to, for example, aloha, right? So my VS Studio Code will auto save my changes and then it will do the live deploy. Let's try to curl again to my local server. You can see the place perform, right? And you can see the result is updated aloha. So this gives you the benefits of uh, speeding up your development time frame, right? Okay. So on the right side here, as I shown in the slides, I have three different environments. Okay, the one at the bottom is my SIT environment, and then middle is my UAT, and on the top is my production environment. Okay, I'm using a infinite loop to curl and call to each of these API I deploy into each environment. For my SIT, there's only one instance, one port. Okay, that's why the message and the host name, so-called the port name that you receive, is constant because it's only one. While for my UAT, I have two ports. That's why you can see the port name is interchanged between two. Then for my productions, there are three ports. So you can see there are three different port names that appear here. Okay, so now I have made my changes, right? I changed from testing to aloha, but all these environment are still remain as the testing. Okay, so now what I'm going to do is I'm going to commit this, right, into my Git repository. Okay, so I'm going to use aloha demo, right? Now I'm going to push into my Git repository right now. So the moment I push this into my repository, it will trigger my Tekton pipelines. Okay, now let's go to my OpenShift console. Okay, so this is my OpenShift pipelines, which is the Tektons. Okay, you can see there's a task that is running. Okay, so if we click into this latest pipeline runs, so you can see this is similar to the slides I was going through just now. So it started by fetching the source code from my Git repository. Then it will do the packaging, do the compilations. Then it will use the builder to build the images. Once it's finished building the images, then it will deploy into my SIT, which is my environment at the shown in the lowest part here. Okay, so the moment it deploy, you should see the message will be changing from testing to aloha. After it deploy the SIT, it will copy the image into my query repository, and then it will deploy the GitOps. In other way, it will push the latest image deployment configuration into the Git repository, and from there ArgoCD will be triggered. Okay, so for the Git, I'm using Git here. So here I have two repositories. One is the one that's storing my applications. The other one is all the deployment artifacts. Okay, in other words, is those deployment configuration YAML file, route services. Okay, so this particular repository is monitored by the ArgoCD. Okay, then I have my query image repository here. Okay, so let's go back and take a look on our pipeline. Okay, so it has been successfully deployed into the SIT. Okay, so we should see the message here will be slowly changing from testing to Aloha. Yep. Okay. So we also can see the image has been successfully copied into my query repository. Let's go ahead and take a look on my query repository. Let's do a refresh. Yep, there's a new image that is being pushed into this repository a few seconds ago. Okay. Okay, so the final step also finished, right? Which is triggering the GitOps. Basically, is committing the changes into this port name deploy by updating the latest images to be deployed. Okay, so let's go and take a look on our ArgoCD. Okay, in my ArgoCD, I have two application configured. One is at my Quarkus UAT. The other one is my Quarkus Productions. So these two configurations will continuously monitor this Git repository to detect if there's any new configuration or new changes. Okay, so there's an interval for the ArgoCD is like a few minutes, but for this demo purpose, I'm going to just refresh it so that it can detect the changes immediately. So you can see once it detect the changes, it will take actions and roll out the new deployment with the new images. Okay, so it's doing a rolling updates where it will spawn the first containers and make sure it's successful. Then only it will scale down the previous one, then continue with the second one. Right. So now you can see in my UAT environment, the message is changing from testing to Aloha, and you can see both of the ports names are different as well. And you can see there are two different port names because I have two instances of two ports here. Well, for productions, it detects the changes. Okay, it shows out of sync here, but this production, it did not automatically go ahead and deploy with the new images because I configure it in such a way that it needs somebody actually to manually click this sync and push the new later changes into production environments. Okay, so this can be served as like a manual steps or approval steps. Okay, so let's go ahead and click on this synchronize. Okay, so it will push the later changes into my production environment. Okay, you can see now it's starting to scale for the first port using rolling upgrade deployment strategies. Okay, right, then now it's going to scale the second one. Okay, so you will see the message changing, the message of the Aloha slowly appears, but you can still see some testing messages in between. that is the lowering update strategies. You will make sure one port is up, and then only sunset the other ports one by one, and eventually you should see all the images being updated and changed to Aloha. Okay, so that's all I want to show in this demo about the new way of doing CICD using Tekton and ArgoCD. Thank you for watching.